Thank you for coming here for Teachers Workshop for our upcoming Great Tennessee Eclipse. And we're very, very hopeful, because if teachers are coming, it means that kids are learning about it. And that's the best thing to do. So let's start laying out our goals. We will try to explain how, even in the smallest ways, why we're so excited about this total solar eclipse, and why is it so much hoopla about that in the news right now. And we also trying to iterate that it is a really good teaching moment, and we already university already created packages for you, so you can actually look at the curriculums that you can go through with your kids. And it's different for the different grades, and you can find all of these materials on website for MTSU Eclipse, mtsu.edu/eclipse. So this is our website, which is already updated a little bit, so you will have extra links in here. And you can see that this snapshot was made, well, some time ago, because right now we're supposed to have 17 days before the eclipse. So what you can see in here, it's a teacher resources. You just click on this square, and it will take you straight to the curriculum. So why do we care so much about the eclipses? I probably will start with the questions that some of you may already know answer for. How many of you witnessed lunar eclipse? Probably, yeah, that's probably what is quite often you can hear about, oh, supermoon, oh, the big eclipse is coming. That's quite often. We will see why very soon. So how many of you witnessed solar eclipse? That's completely different question. And here we have a John who actually saw it. Well, I also saw it. Once in my life, I was a little girl, and all I remember is that it was very scary because people around starting to scream. I missed eclipse because of that. Okay. So to understand why they're so rare and why is it such a big deal, we need to understand, first of all, the geometry of the system. So we will need to talk about, first of all, lunar eclipses and how they happen and when do they happen. So we need to understand the general geometry of the Earth and the Moon system. So say this is my Earth. So this is very close to the basketball. So since we are in the physics department, we were looking for the basketball, and this is the only thing that we found. So if this is really good size for the basketball, that's actually quite good, right? Very good. So what would you think would be the size of the moon? There are some balls in here. Golf ball is a good question, good approximation. Well, a little bit too tiny maybe. Moon on a stick is a little bit too big. So actually the best representation is here. It's a softball size, well, baseball size. Sorry, you see different culture. Baseball size. So it's a quarter of the size of the Earth. Okay? So when do the lunar eclipses happening? When the sun, and now Chuck is a sun. So this is the sun. And the light from the sun illuminating the moon. You see it's illuminating? Well, probably you don't. Should we kill the light? You can see that? So illumination of the side. So you see only half of the moon all the time, right? Doesn't matter where it is. It's a half of the moon all the time. You see? Illuminated. So that's what we have. when the sun is hitting the Earth and Moon system, only half of the ball will be always illuminated. But how we, tiny humans, will perceive it as we sitting on the surface of this globe, that's completely different story, right? So what will we see? We see the moon, which is here, right? And as Earth is rotating, and moon is rotating, in the wrong direction. Moon is rotating around the Earth. We will observe different phases, because when the moon is like that, I am sitting here on the Earth and I see the full moon, right? When I'm in here, I'm sitting on the Earth, I'm looking straight at the moon, and I see the left part illuminated and the right part dark. And that's the last quarter. Last quarter before the full moon, where I see nothing, because there is no light hitting it. You see that? Okay.
You mean new moon?
New moon.
Yeah.
What did I say?
I thought I heard full, but maybe
new moon.
Yeah.
If I did just completely, yeah, this is a new moon, right?
Okay.
And this is when it completely illuminated the full moon. Okay? I started at 8 in the morning today. Okay. So we are going through the different phases of the moon as moon is rotating around the Earth and making this loop around in 28 days, right? And then repeating itself. Okay. So what happening during the lunar eclipses? It means that we're supposed to see the moon, but we don't see it at all. Well, almost at all. We don't see it. Why? That's because the shadow of the Earth, as we saw this, let me be a little bit closer to the sun, and sun will start shining. So the shadow of the Earth will cover the moon if moon will be in the right position. And shadow of this big Earth is quite large, so it's covering moon quite nicely. So we see everybody on this side, on the night side of the Earth, will see the eclipse. You see, so everybody who's in here, so let it rotate a little bit, so everybody will be exposed to it. You see that? Everybody in the night side will be exposed to it. Thank you, son. Now, during the solar eclipses, completely different story. Well, what happens in the solar eclipses? We have to have, once again, three bodies somehow aligned with each other, but in such a way that now we humans on the Earth will not be able to witness the sun. And the only time when it happens is when, so we here on the Earth, well, let's see that United States is looking at the sun. So this is during the day, and right now I'm getting blind because the sun is actually shining straight into my eye. But if I will,
You hold it and see if you can see a shadow.
But if you will have the moon on the way, I can hide it, right? So somewhere here, I can see the shadow of the moon, okay? So what's the difference then? Why is it so often for lunar eclipses to happen and so rarely for the solar to happen? If all of this is just, well, switch these two guys around, and that's it. Well, the difference is actually in size. Okay, so when do we have the total solar eclipses? It's that where the disk of the moon is completely covering the disk of the sun. So this is a very fine-tuned problem. So in our location in Middle Tennessee, and definitely in the center of the universe, MTSU in Tennessee, in Murfreesboro, when did the last solar eclipse happen? So this is a question for you, and these are some choices. 20,000 years ago, that's, you remember, who is that? It's Smilodon, right? That's what was found, and that's why we have predators, right? It's a favorite animal. We also have, well, 65 million years ago, somewhere here, we had a dinosaur roaming, right? If it wasn't the ocean at that time. But, well, who knows? It's so far away. Or was it 500 years ago, approximately? Or was it like 65 years ago? And this is one of the pictures, nice colored pictures from the Murfreesboro. So which one do you think is the closest? 500 years. You probably already saw some news. Yep. So it's actually last occurrence here in this area was in 1578. So to put it in the historical perspective to yourself, Columbus will need 25 more years before he will actually set a foot in the Caribbean. So after 25 years, so it was a solar eclipse in the Murfreesboro, and then Columbus decided to come to the Americas. 15 years ago. 25 years ago, that's when 25 years, that's for Leonardo to create the Gioconda. And only 120 years later, Shakespeare will actually write Romeo and Juliet. And, you know, that's kind of to put stuff into perspective in our historical thing. So next one will be when it will be 2566. So that's probably a most fair rendition of what Murfreesboro will look like. In one of the meetings, somebody said that this looks like a Sonic. There is no plugins in here whatsoever, okay? So, this rare opportunity, in average, for the location on the Earth, in average, for the same location on the Earth, happening in approximately 375 years. But in the same location, it could happen, the closest is 18 months, and it is happened like about 15 years ago in 2001 in one place in Angola that it actually took just a tad less than 18 months, so that was absolutely stunning. And some of the researchers who doing these calculations for different locations on the Earth actually found the places where the solar eclipse will not happen for 3,600 years. So that's quite a rare event, especially in the places where it doesn't happen in the 3,600 years. So that's quite a big opportunity, right? So theoretically, the longest duration for eclipse that could happen is about 7.5 minutes, and that happens once again if you will look very carefully on the geometry, about which we will learn in just several minutes. So our upcoming eclipse that we call Great Tennessee Eclipse because, well, once again, it's the greatest when it's in the Tennessee, but, you know, let's give our friends from the north a little bit of favor treating, you know, it will be a little bit longer in Kentucky. Okay, so let's look at this geometry and understand why is it so rare. So we already looked at the sizes of the Earth and the Moon, right? So the Moon is approximately, let's put it properly direction, Moon is approximately 1/4 of the size of the Earth. Now let's try to put them in a proper distance, okay? So if this is the Earth, where do you think I should put the Moon? Let's start from the obvious choice, just touching each other. That's probably just a tad too close, right? It will not take us that much to overdeal to go to the Moon, right? So where should we put it? You just yell, where should I stop? Closer? You think it's a little closer? Yeah, because, you know, that's what we see in the books all the time, right? So let's try to actually put it in the perspective, in a proper perspective. So the distance from the Earth to the Moon is approximately 30 Earth radii. That's good, right? It's about 10 meters.
30 diameters.
Diameters.
Yes.
Diameters. Right. 60 radii, 30 diameters. 30 diameters. You think it's not 10 meters? Okay.
Well, we put 30
Okay.
of these side by side by side. And get almost across the room.
Yeah, across the room. So that's, usually we're doing it when we have a squares, you know, and I can count the squares. Okay? So that's a distance. Okay? Now, so that's what we want to do right now together with you guys. So a little bit hands-on activities. So what I will give you right now, I will give you 1 inch diameter, not a radius, diameter of the Earth.
Two per person.
And 2 per person, yeah. And we will give you yardstick. So this is your Earth, this is your yardstick. And you also want to have 2 clips.
Okay.
Oops. That's your Earth. That's your clips. This is your yardstick. Do you have an Earth? Everybody have an Earth and clips?
I need
Do we
clips.
have enough clips?
More clips?
Well, I thought it was supposed to be. No, we have more.
2 more.
2 more. Okay, now.
You have clips. You need one.
So you have a rulers in
and
your
you
hand,
need
right?
One more. Let me go get it.
So what I want you to do
Clips.
right now is to take this Earth on a toothpick and put it somewhere at the beginning of your yardstick, say at marker 3. Just clip it with the clip at the marker 3. Just mount it with a clip, yeah.
In there.
And so it will be sticking out like that
Okay.
at 3. Perfect.
Awesome.
So may I use yours because this is just a perfect model, okay? So this is the location of the Earth. Now I will give you a little bit of Play-Doh. Now try to make a little ball of a size in a diameter of 1/4 of the inch. Because what you have is right now what you have in your hand, these little balls, they are inch in a diameter. You can actually measure it should you want it. So 1/4 inch in a diameter, how much? Try to put it on a stick and see if it's a 1/4. Yeah, so that's a little bit too big. So you can see that actually 1/4 inch in the diameter, quite a little thingy, right? So remember that the size of the Earth in a diameter is 1 inch. What we want to do, we want to put 1/4 inch of a diameter of the Moon at the location which is 30 diameters away. It means it has to be, if you started at 3 inches, it has to be 33 inches, right? 33 inches away. So do you have enough toothpicks? You need more toothpicks? I didn't give any, because, you know, toothpicks is so important, such an important, they're extremely expensive. Yes. So this is your Moon now, compared to the Earth that you have, okay? So now imagine that you are the Sun, because, well, we are all the stars, right? So turn the stick such a way that you can see the Earth in front of you. Okay, and try to look through the Earth and try to cover the Moon with the Earth. It's quite easy to do, isn't it? You flip it a little bit, it's quite easy to do, right? If your hand is not steady, it's still quite easy to do. Would you agree? Now turn it around. Now you continue to be the sun, and you covering the earth with the moon, with tiny, tiny little moon. Okay? Now, if your hand is a little bit unsteady, it will go away. You see that? So the plane in which moon is rotating around the earth is tilted to the ecliptic. Ecliptic is a plane to which earth is rotating around the sun. And it's tilted just a little bit, 5 degrees, but this 5-degree angle gives all this difference. Okay? So later on, when we will go outside, and we will be looking in the sun through the sunglasses, special sunglasses, we also will be able, if it will be bright enough and if we will have enough patience, we will be able to recreate the solar eclipse and lunar eclipse using this model. So just hold on to it for a little bit. Okay? So that's what we have.
Your clicker forward, backward.
So that's what we have for our geometry. The moon, as it goes around the earth, is tilted at 5-degree angle. So how often does it happen when the moon, earth, and the sun could be at the same line, so eclipse is happening? Well, not that often, right? It will not be every time when the moon happen to be between us and the sun. You understand that just from the geometry? So now this is a really, really good video provided by NASA in which the Earth and the moon put in the proper distances, and we will look at the geometry of this particular experiment. So what do we see? We see that the moon is rotating around the Earth, and the shadow of the moon is hitting the Earth in a, oops, it's not hitting. Why? Because at this particular moment, my moon happened to be underneath the Earth. The shadow of the moon was underneath the Earth. And in a very precise moment, when they're very perfectly aligned with each other, this narrow shadow that is left, because of the cones of the light, this narrow shadow will hit the Earth. Okay? And that's where it's hitting the Earth, that's where we will see the total solar eclipse.
So are there some places that will never experience it because of their location on the globe?
That's absolutely correct. That's some of the places on the Earth may not see the total solar eclipse for 3,600 years. 3,600. Yes.
I'm assuming they're closer to the pole? Or does it?
Well, I actually don't know.
It's okay.
I'm sorry. I need to look it up.
Hard calculation. It's probably really random places.
Is it random?
It could be very random, but
The rotation, yeah.
and tilt and wobbles and all this kind of stuff. But I don't know. So why also the total eclipses are so rare? Because in average, the distance from the Earth to the moon is 30 diameters, in average. But actually, the rotation is happening not around the center of the Earth, but around the center of the mass of the Moon and Earth system. It happened to be that this center of the mass right now laying inside the Earth, but it's slowly moving. So what will we have? We will have two extreme distances. One extreme distance is called apogee, and it means the moon is away So that's how I remember these strange words. A apogee away from the Earth. And sometimes moon is pretty close to the Earth, and that's a perigee. So you see these distances are, well, looks like not that much, but it is enough to produce the dot, this black dot of the shadow on the Earth, or not produce it at all. So when moon is a little bit further away, this dark spot of the shadow does not hit the Earth. And we will have annular eclipse. It means the moon, as it covering the sun, will not cover it completely, but we will have a very narrow ring around the shadow, around the silhouette of the moon. But even a tiny ring around is enough to make our day. And we will have a little bit of dimming of the light, but we will not have complete darkness. In the case of the total solar eclipse, we will have this region of the Earth that will be completely covered from the sunlight. And that's where we will see just a dark disk in the sky that has a little bit of hair sticking out. And that would be a solar corona, about which Chuck will say very, very soon. And this is completely different experience. So that's why total eclipses are such a big deal. Okay, so everything has to fall into the places. So what will happen to us on August 21st? The shadow of the moon will fall onto the Earth, and it will start its motion through the Earth. It will start somewhere in the Pacific, but it will enter the most important place, United States, in the west, and then slowly at the speed approximately 1,600 miles per hour, move along the continent to leave us in Carolina. So almost in the middle of this path is the middle, Tennessee. Shadow by the size will be not that much. It will be about 70 miles. So it means that everybody who living in about like 200 miles from the shadow path, being in the right mind, will definitely move toward. So expect a lot of traffic delays in both directions. So you will have a jam from Chattanooga to Nashville, and we will have a jam from Louisville. Or, well, you know, from north side. And that's why I leave you guys for a better person.
I don't know. Very good.
So you tell me if you can hear me.
The audio's okay?
All right, do you want to score big on your next Scrabble game? Syzygy. Syzygy. It's a three-body alignment. It doesn't necessarily mean astronomical, but in this case, if you have three things in alignment, it's a syzygy, and of course that's what we have for a total a solar or a lunar eclipse. I'm going to fall. I'll trip over these if you don't move them. So I'm going to move them before I do. So Irina mentioned the tilt of the lunar orbit. So every 6 months, the orbit of the moon, the Earth, Sun plane, and the lunar orbit plane are tilted 5 degrees. So when they cross, they make a line. And that's called the line of nodes. So every 6 months, as Earth orbits, the moon has the opportunity to line up with the Earth and the Sun. But as she said, it does not happen. And the phase of the moon isn't quite right. or your location isn't quite right. So all these things have to come together for you to have a total solar eclipse. So a syzygy is a set of a fun word. So the other cycle that causes the eclipses to be so rare is called the Saros cycle, the sun cycle. And that's an 18-year cycle. And you can see eclipses marked on the map here. So these are the paths of totality separated by about 18 years, one Saros. So notice, if you're in 1999, one happened over Europe, notice the shape of the path of the shadow 18 years later. But you see different longitude, different part of the Earth. And then here's another pair of eclipses. 98 and 2016, you see the shadow path looks very similar. And then here in 2002 and in 2020 in the Southern Hemisphere. So not only do you have to get the moon phase correct, you have to get the syzygy, the alignment, correct every 6 months. Then you have to get the phase of the moon correct. New for a solar eclipse, full for a lunar eclipse. You have to be in the right longitude. And then notice how these shadow paths change in latitude. So you have a changing latitude because of the changing orientation of the moon. So every 54 years, that's 3 Saroses, you're kind of in the same longitude region, but not the same latitude region. So hence why, on average, it's 375 years for one location to have a solar eclipse. Lots of things are going on here. So as she showed you, the path of totality starts in the Pacific, crosses the U.S., and ends up in the Atlantic, 75 miles wide. So again, the impression I want to make on you is this. Let's see. You take that one. So 30 Earth diameter, and then the sun coming from over here, and the shadow, the dark shadow, the umbral shadow, was a cone-like shadow coming from here, getting narrow, all the way down 75 miles wide. So that dot is, because of the different sizes, is why this zone, this path of totality, is so rare, and it's going to be so exciting. And you see, if you're just out of the path, just a few miles, you might see a 95% solar eclipse. So you will see the maximum coverage of the sun, will leave a sliver of the sun. So where are you located? Where is your school? Church Street. So you're kind of north of I-24. Yeah. Okay, you're good. Where are you? Laverne.
May not be.
Church?
South yes, you'll be okay.
I think you're okay. Laverne, you're good. You're going to get a minute. So we're going to get about 1 minute and 5 seconds of totality here. Laverne, you'll probably get, I just was in Smyrna, and they're going to get 1 minute 30 seconds. So you might be 1 minute 40. Yeah, you're closer to center line. Where are you located?
I'm not sure where I'll be on that day.
Oh, okay.
Probably Nashville.
Nashville. Okay, so that's 2 minutes. Okay. And your school? You're in Smyrna. 2 minute and a half. Murfreesboro. Ah, okay. So everybody here is in the path. So if you're south of I-24, if you're down closer to Christiana or something like that, you got to move. You're in 99% zone. Why not drive the 10 miles and be in the special zone? That's what I'm trying to impress on you, is that
I'm living here in Murfreesboro. My apartments will not have a totality.
you're not going to be there, I'm sure, right?
No,
Yeah.
I'm gonna be in my apartment.
Yes,
I'm gonna be
yes.
on campus because campus will have to speak.
But you notice too that the entire North American continent and some of the South American continent will see part of the eclipse. So the partial phases covers entire northern hemisphere, essentially, North American hemisphere. And so if you're in Texas, you're going to get a 70% solar eclipse. And if you're in Central America, you'll see just a little cutout, a little bite out of the sun. And up into Canada, you'll see a 30, 40, maybe 50% solar eclipse. But it's a completely different phenomenon. A partial eclipse versus total. And I've heard you guys talking earlier about how many of you have seen it and where you saw one. 79, right? So some of you, 70. Okay, because there was the last one to hit, the last total eclipse that touched the continental U.S. was 1979, and the totality was Oregon, Washington State. So partial here.
Well, and Winnipeg, and Canada.
Hmm?
Canada as well. Let's go into Canada, serving Northern Territory.
Yeah, okay. But we have to talk about the most important place. So 79, and then but there was one in 90. Somebody mentioned 96 or something. Hawaii and Mexico, Baja, Mexico. But we saw a partial here in the 96 or 8 or something like that. You have this narrow path which we must get to. That's the fun part. So the moving in, zooming in, the place of greatest eclipse is southwest Kentucky. They're going to get about 2 minutes and 40 seconds of totality. And then you zoom in, and here we are. We're at the southern edge. So we're going to get about a minute, maybe a minute, 5 seconds. But if you live in Spring Hill or Franklin, look at Franklin. They're out of luck. Shelbyville, Tullahoma. They are not going to see totality. They will not be able to take off their solar eclipse glasses. It will be a cool experience, no doubt. A 95% coverage of an eclipse a partial eclipse is really cool. But totality is so much better that I'm hoping many of those folks will move into the path of totality. And you see the center line comes across a little bit north of Nashville, and that's 2 minutes, 40 seconds. You go over to Sparta, it's 2 minutes, 39 seconds. 1 second difference. The difference is how close you are to that center line. Now, 1 minute and 30 seconds to 2 minutes is not enough to stress over. Right? Don't move for that reason. If you're in Smyrna or you're in Laverne or something, you're fine. You stay put. We're just on the edge of okay here in Murfreesboro. We'll get a minute. For us to move campus, 30 miles north, it would be crazy. So it's not important for you to dash to the center line, because 2 minutes of totality is going to be just as awesome as 2 minutes, 30 seconds of totality, really. So if your friends ask you or whatever, just get them in this zone and they'll be fine for all practical purposes. And there we go, just a little bit closer shot of where we're going to be on the southern edge. And in a weird way, this might be to our slight advantage here, and I'll explain here in just a moment. So we're inside, so here's I-24. So you can see it's not quite the same, but I-24, if you're south of it, that's the real sort of the danger zone of you may not see totality. You need to be north and east of I-24. Looks like we're going to be okay. I cannot stress enough how once-in-a-lifetime experience this is going to be for you and your students, your family, whatever. It's that amazing. So what we're going to be doing here on campus is at 11, we're expecting maybe 10,000 plus here. We're not sure. That's my guess. We have no idea. No idea. Right now, confirmed, we have about 4,000 Rutherford County students and city schools students coming here among faculty and everything that will be on campus.
You have students coming from Alabama.
Yeah, we have students coming from Huntsville and Florence. I just got a call yesterday, a teacher from Wayne County down on the Alabama line, Waynesboro. She wants to come here. So I said, tell me if you're driving a bus, because we need to know if we have to park a bus. Otherwise, come on. So we're going to have live music. We're going to have a stage set up with speakers and live music for about an hour and a half. And then we'll have plenty of telescopes set up. We're going to have an Ask an Astronomer tent. John Wallen and myself and Ron Henderson, we're going to be kind of interviewed on the stage, and we're going to be talking about some of the same things you're hearing right now, just to prep the crowd as to what they're going to see. Yeah, so we have a hands-on activity. We're going to build a pinhole camera, show you how to do that, and we'll have, as I said, telescopes, binoculars set up for safe viewing. So in Murfreesboro, the eclipse begins at 11:59 a.m. So we call that first contact. So when the edge of the moon just touches the sun, and for about an hour and a half, it takes the moon, it will slowly cover the sun. So you have an hour and a half, approximately, to casually look at the sun with your solar eclipse glasses on. You can look through the telescopes with a special solar filter. Plenty of time. Nothing's changing that quickly. 1.5 hours before totality, and then 1.5 hours after totality. So there's no rush to grab glasses and have them on for 1.5 hours. You can just take your time, look at the sun for 20 seconds, and then go about talking to people, and then look again 5 minutes later, and you'll see that moon slowly cover. So about 1:29, for 1 minute, that's what we call a second contact, totality begins. But let me just impress on you, so about between 12 and 1, you're not going to really see that much change. The first hour, you just don't notice it. The sun is that bright. But starting about 1, maybe a little after 1, you're going to start to see, it's just a little strange. The sky is kind of twilighty. And of course, you'll be looking at the sun. You'll see the shadow of the moon covering more and more and more of the sun. And at 1:15, it gets a little bit darker, and you'll start to notice, if you think of it, notice your shadow. Your shadow on the ground is a normal a normal day. It's very kind of blurry because the sun is a large object. But when you start to squeeze the sun or cover the sun, you get very sharp shadows, very sharp. If you're standing near a tree, look under a tree during the partial phases. You will see little slivers of the sun, hundreds of them all over the ground under the tree, because the tree is acting like a pinhole camera. And because the sun is now smaller, it gets those shadows get very sharp. It's a beautiful a display under trees. So if you have students, you think of it, well, in this case, you probably have 30 minutes before and after. It's like, go under a tree and look, or take a photo if you can of that experience. So 1:29, totality. What is going to happen at this point? People will scream. I mean, you will hear it. You might hear it in Laverne, the MTSU campus screaming.
How dark does it get? I mean, are we talking like nighttime dark?
Pitch black kind of dark? Yeah.
Your eyes, is that dark?
Great. That's a great question. So when I'll show you some pictures here in a moment, but when the moon covers the sun, it's covering the disk of the sun. So that's the hot ball of gas that does make up the sun. But around the sun, there's an atmosphere. It's a very thin atmosphere we call the corona, the crown of the sun. And that will, because the brighter sun is covered, you will see this veil of light around the sun, and it will be about as bright as a full moon. So it doesn't get pitch black. It's going to be like if there was a full moon out.
I teach kindergarten. I'll have 5-year-olds.
Yeah. Well, but they won't be scared. No, they won't be scared.
It sounds like it's a kind of a come and go thing. We come out, see it kind of the onset, go back in, and you go back out later. You know, just really.
The key time is 1:10 to 1:40. That 30-minute window. That's when you want to be outside. But as I said, you've got an hour and 25 minutes before and an hour and 25 minutes after to.
Now, you don't want the kids to move around, actually, because they will. It is dark enough. They're
Yeah.
be adjusted.
Everybody's eyes won't be adjusted to the light. Yeah.
During totality, can you take your glasses off safely?
Yes.
To see the eclipse.
Great question.
Now, they need to take their glasses off only during the night.
Great question. And this is important because I'm amazed at the amount of misinformation that's out there. So partial phases. You can see any part of the sliver of the sun, glasses on. These things are so dark, we're going to go try them here in a minute. They're so dark you can't see anything but the sun. So when the moon covers the sun, if you have your glasses on, you won't see anything. Take the glasses off during totality. Don't believe any myths or weird stories about it. You will miss the event. Your kids will miss the event. It's perfectly safe to look at the sun when the moon has covered it completely. You will see the beautiful corona. You will see, so darkness is falling across campus here. I've got some pictures I want to show you of what it's going to look like. So 1 minute, though, it's fast. 1 minute goes by like that when you're excited. So you have to be, if you've got kids, especially young ones, you've got to tell them, glasses off, glasses back on. Yes, I mean, just be firm that way. It's like, all right, everybody's glasses back on. Absolutely. Just to be safe. Also, think common sense. No one looks at the sun. You just won't do it naturally. If you do, your eyes will avert because it hurts. A 5-year-old knows this. They're not going to stare at the sun for a minute and hurt themselves because it hurts, and they won't do it.
It's actually a little harder close to totality because people, at the 99% block off, it doesn't hurt as much. So you've got to kind of tell them.
Yeah. Yeah, the last little sliver and the first little sliver. Well, again, you'll see it. You'll see it. It gets dark, and then when the moon moves off and you start to see the sun back again, you'll know. Yes, it's pretty obvious.
See sun again. That's most important to put glasses on because your pupils are dilated, and because it's dark, and all of a sudden it will become.
It's going to hurt.
So that is when it's better to have them on.
Yeah. The real key, and so you're not going to damage your eyes if you look at the sun for a second or two. The real key is you do not want to be looking at any kind of optical device, binoculars, telescope, none of that. Especially with young ones, just don't do it. All they need is their wonderful eyes and the glasses on, off, back on. It's very simple, and that's easy. It makes it easy. Yeah. So we're going to be going all the way until 3 o'clock here when the final eclipse is over. But as I said, by 1:45, 10 minutes after totality, all right, I'm done. All right, I'm going. You know, people are going to start leaving. It's just, especially if you've built it up, and you've seen the partial phases at the beginning. It's the same thing going on the back end. But if you've got the advantage like we do, we have telescopes set up, and you didn't get a chance to look at the sun through a telescope before, now's the time to look with a special solar filter on it. You can see the partial phases. So here's some beautiful pictures of the partial phases and again the total phase. So you see the corona here. And you will see some neat things right before the daylight changes. Right? It's going to get dark. You'll notice, if you're in a place where you might watch animals, you'll notice the animals get very quiet. Birds stop squawking. They roost. I'm not sure if crickets will stop chirping. I think they do during totality. They might start chirping because it's evening. They think it's evening time. Dusk is setting. But during totality, everything is weirded out. So it gets quiet. Nature gets very quiet. And if you're in a place where people aren't screaming, you might notice the birds not chirping or animals being quiet. I don't know what a cow or a horse would do, but you know what I'm saying? It's just kind of a neat experience to see this changing light. John? Cicadas, I don't know. Yeah. Just before totality and just after totality, you will see beads and rings. So you see this image right here? So that is the edge of the moon, which is not perfect, right? There's mountains and valleys on there. So right before totality, you'll see little shimmers of light through those mountains and valleys on the moon, and you'll get a big blob of light. So it looks like a diamond ring. So there's the diamond, and then you have the ring around it. So that's called the diamond ring effect. I'll show you Bailey's these beaded patches of light here in a moment. You might notice a temperature drop. And that is a neat experiment to do with your kids. If you have a thermometer and a camera or a way to record a thermometer, digital thermometer or something, just turn it on. Put it in the shade. You don't want it in the direct sunlight, but put it in the shade and let it run for 3 hours and see if you notice the change in temperature. I mean, that's something that your kids could do as a science experiment. Simple.
How much is it expected to drop?
10 degrees.
10 degrees.
Yeah. Yeah, you might see a 10-degree drop on that day. The nature, again, changes. The animals will change. As I said, your shadows get sharper. And you know this at nighttime, you lose color. Think about driving at night. Everything's kind of grayish. So you may notice that the trees aren't green as it gets dark. You know, you're losing light and your eyes don't need bright light to see color. So at night, things get grayish.
I have to leave. I have an open house in 15 minutes. Is there a way I can get this?
Yes. mtsu.edu/eclipse. Click on Teacher Resources, all the way at the bottom. This presentation is there. Okay, you're welcome. All right, how are we doing in here? All right, so let's move on ahead. So these are just some nice photos of the diamond ring. And here is these beads of light. Just before and just after totality, you'll see these little blobs of light. The corona. Here is a magnified view, but the corona, which is the thin atmosphere around the sun, looks different every solar eclipse because the magnetic field of the sun is different every time. So that's something that you can see with your eyes. You know, that's a beautiful photograph of it. You won't see it in that much detail, but you will see perhaps little streaks coming out of one side or the other. So here's what the sky will look like during the daytime. 1:30 in the afternoon, you will see planets. You will see stars. And the first one you will see to the right will be Venus. That's the brightest object besides the sun or the moon in the sky. That will pop out. And then to the left, you'll see Jupiter pop out. And then you might just start to see a few other of the bright stars. Mercury will probably be too dim to see it. Mars, probably too dim to see it without magnification. But Venus, Jupiter, and you might see a couple of the bright stars. Regulus is a pretty bright star, but it's close to the sun, so it may get kind of overwhelmed by the corona. But just look for planets and stars in the sky. That is something really, really fun. And Irina mentioned this before, but this is an image of what we call the annular eclipse. When the moon happens to be a little bit farther away than average, it doesn't completely cover the full disk of the sun. Because it's kind of interesting that the sun is 400 times the size of the sun. So the Earth is 4 times bigger than the moon. The sun is 100 times bigger than the Earth. So Earth is the basketball. The moon is the baseball. What's the sun? A sphere the size of a basketball court. That's how big the sun would be. And how far away would it be? 2.8 miles. So kind of wrap your brain around that a little bit. So 2.8 miles, then I got a basketball, and then 10 meters, 30 basketball diameters, then I have a baseball. That's the correct scale of this whole thing. So if it's a little bit farther away, it won't cover up the entire sun. So there is a pro. That is 55 images of the sun stacked together under perfect, ideal sky conditions in Mongolia to get this incredible image of the sun. It's beautiful. Now you can't see that kind of detail with your eyes, but it's an amazing, amazing picture. Look at the moon. You can actually see detail on the lunar surface. And that is because Earthshine. So that's reflected sunlight, a little bit of sunlight off the Earth back onto the moon. You can actually see the moon is a little bit illuminated there. It's just amazing. All right. What are you going to feel? What are you going to experience here? Let's do this. Isn't that cool? So what you may not have noticed there is they had a solar filter on that camera, and then they tore it off, and that's why you notice that quick change. And I don't recommend doing any of that kind of thing. Just experience it. Let the pros do the pro things, and for you and for me too. I'm not doing anything. I am going to have glasses on, glasses off. I have a pair of binoculars too. I'm going to try that. But I'm not going to do anything fancy because you'll miss it. Your students will miss it. Just enjoy the experience. And let me just, yeah, John?
And none of the astronomers in MTSU, none of the physics departments are going to try to take any pictures during totality. You just want to experience it.
We've got some fantastic MTSU folks. They've got solar filters on their video cameras. We'll have a video camera on our telescope right outside, and we're going to live stream that. And other people, NASA will have live streams going on, so there'll be plenty of opportunities to see pictures and get videos later. You and your students should just experience this.
We're going to live stream it because Rutherford County is giving parents an option for them to say that their children cannot go outside. So for the ones that
Right.
their parents do not want them outside,
Right.
well,
There's the legal department.
right.
Yeah.
So I don't know if parents are going to take that option.
Yeah.
I don't know, but
So-
it's nice that they can watch it.
Yeah.
live stream.
Well, Nashville Metro decided not to close the schools because, again, they were worried that they didn't want children being unaccompanied during this. And I don't agree, but you know they got more at stake than I do to say this. But again, kids are smart. They're not going to hurt themselves if they look at the sun for half a second. So supervision is always better, but take your kids outdoors to see this thing. Let me maybe be overly dramatic here. This is a once-in-a-lifetime opportunity for you, for your kids, your family. Get them here. Get to the total eclipse zone. You will remember it for the rest of your life.
Do you chance anything in Spanish or other languages to help translate that to parents? We have a high population of.
Oh, what a wonderful question.
To let them understand.
I'll tell you what, if they don't, I guarantee that people are.
Yes, and the NASA folks might.
Okay, that's a great.
Yes, and I bet NASA will have, somebody will live stream it in Spanish. Yeah, I would think so. Yeah. I mean, this really is going to be the most witnessed, photographed, videoed, filmed, whatever eclipse probably of all time, up to this time. So there'll be lots of opportunities to see it. But there's nothing like experiencing it yourself and with kids or family around you. It is, I was joking, like people will have come to Jesus moments or Allah or Yahweh or whatever, you know what I mean? It's going to be that dramatic. People will yell, as you heard. People will cry. People might propose during this event. Yeah, it's that amazing of an experience. So educate people, your students, to educate their families. Take off work. Take a late lunch.
Question about like where we'll be or whatever. Is there? This may be a silly question, but as far as light pollution in cities versus going somewhere where there's more, I mean, is that a consideration, or will it be as awesome regardless?
It's going to be awesome regardless, but that's a fantastic point. I'm glad you brought that up because streetlights may come on. It's hard to gauge, what kind of delay the streetlights have, but it'll get dark, slowly. And yeah, you might see streetlights come on, but it's not going to affect your experience unless you're, because you'll be looking south, and the sun it's mid-August, midday. The sun's way up here, so you're looking up. And unless there's a streetlight right above you, just come over here, and it's going to be awesome. Yes. It will get dark, like. It might even be that much more awesome. Yes. Great point, though. I'm glad you brought that up.
What's the concern about driving during partial, like before the totality and after? Is there a concern about that?
No, but the concern about driving is on Monday, August 21st, it could be insane. The amount of traffic could be.
I'm thinking about our dismissal time for the end of school, like.
What time do you dismiss? 3 or 3:30 or 2:30? And where are you located again? In Smyrna.
Elementaries are always about 2:30 to 2:45.
Okay.
And then middle school's a little.
Okay.
So we were just thinking about like our dismissal time.
I think it's going to be crowded, especially around Smyrna. I mean, you got to have your normal traffic, but then you're going to have all this extra traffic. But I just don't know.
I think driving safety, there's no issues.
Yeah.
In terms of traffic, there is, but in terms of lighting, there's not.
Yeah, that's not going to be a problem.
To drive through our parking lot to pick up the television.
No. 10 minutes after totality, there'll be enough light that you won't need your headlights on. Yeah.
Would need to impress upon the children if they're on the bus or in their car and it's still partial, they would still need their little glasses
Absolutely, yeah. If they want to look at the sun. But 15, 20 minutes after totality, it's going to be bright enough that people might even forget. Oh, there's, you know what I'm. It's a normal day. After that, the excitement's over. 15 minutes after it's over, that's and you won't notice any change probably unless you look, you know, at the sun. So I don't want to keep you too much longer, but just I've already mentioned a couple of these things about safety. So if you have an optical device, you need a solar filter. You need solar glasses. The only non-special solar filter glasses that you can use is welder's goggles number 14 or darker. So don't let anybody say, well, I've got this old photograph that's been exposed, like old film, or I've got a lighter and I smoked a piece of glass and darkened it. No, won't work. You've got to have a super, super, super dark glass. Again, stand under a tree. You'll see these really cool effects during the partial phases. Real quick, the projection, pinhole camera. It's very, very simple. Take a piece of cardboard, cut a hole in it. Get some aluminum foil and tape it over the hole. Then take a pin and try to be symmetric about it. And take a nice a pin and make it a nice hole. And then you just need a white sheet of paper, a light sheet of paper. And this may or may not work here, but you will see, depending on how far away you hold the paper, you'll see the image of the sun. We'll try it outside here, but it works very, very well. Yeah. I mean, you're going to see a sun pretty small. I mean, it's going to be this size, but it's a great way great experiment to do, and then they'll see a little sliver of the sun in partial phases. But during total, look, right? I mean, you want to look straight at it. Okay, so for the last thing we want to do, so mtsu.edu/Eclipse or the NASA site is fantastic. They've got awesome videos, great images, education sites, all kinds of stuff there. So I can recommend that site. You guys want to try the glasses? Let's go. Let's go outside.